Good morning, everybody. I hope you have been having a good Deepavali. So I will just wait till people join in. So I circulated a Google form asking about how you would like the course to continue. So I didn't hear from many of you. So the danger of not responding to a form like that is that it will be driven in terms of what the minority class feels. Okay, for example, what I get a sense is this course is towards the heavy side, so we need to probably reduce the workload, and people seem to enjoy programming more, so they are asking for more programming type of assignments. So if you feel like these are good things, yes, by all means, don't respond to the forms. But if you think this is too much, then you please put in your views. All right. So so yeah, so tomorrow I will have Varun teach a little bit of NumPy. So Varun and Rajat together, they will teach a little bit of NumPy. Is Varun here? Probably not. Okay, so your TA is going to teach you a little bit NumPy tomorrow, and we will also have a little bit more programming assignments. Okay, so that's what is going to happen. So, all right. So I hope I'm audible.
Yes, sir.
Yes, sir, you are
Yeah,
audible.
okay. All right. Okay, so let's get started with today's class. Okay, so we were discussing the topic of, let me choose a more bolder pen. And then we were talking about conditional probability and conditional expectation. Okay, so one of the most like, you may be wondering why this topic I'm talking about so much when the MIT lectures were only one. The reason is this is a important thing in machine learning. So if there are two types of supervised learning problem that you're all familiar with, I mean, you may be familiar with, you're not expected to, but in case you are, so you would know that there are two types of problems. So one of the problems is called classification. Okay, so here what happens is you are given like, what you have is a huge data, and then each data point. So let's assume, for example, let's say you look at your seniors of yeah, so maybe let me choose a example which you can relate to. Okay, let's take a simple case of recognizing cats in a picture. Okay, so recognize cats. So what you have is pictures. Okay, these are all the pictures that you have, and there are different types of animals here. So one may have a, dog. So this could be a dog, and then there could be a cat. All right, so, and then there could be a cow, and so on. Okay, there could be a cow. Okay, something like this. So these images are there, and whenever there is a cat, so this is a cat, there will be a 1, and whenever there is anything other than cat, it will be a 0. Okay, so this is known as a classification problem. Okay, so you are given pictures, and each picture has a label. So these are called labels. Okay, and the labels denote something. So what do the labels in this case denote? 1 means 1 is a cat, 0 means no cat. All right. So this is just a very toy example, but you can also do, for example, look at X-ray images, okay, and then X-ray slash CT, and then you can say one means let's say COVID positive and zero means COVID negative, right? So this is one of the gold standards. You can do a CT on a patient to find out if the COVID has percolated into the lungs, or you can look at I don't know, MRI and then talk about brain tumor, and all these kinds of important applications are there. Okay. So let's take a simple, harmless example of recognizing a cat. All right. So these images are there, and what happens is you are given a huge training data. So huge training data implies that you are given a ton of these images, and each of the images have been labeled properly by some expert. Now, what you are supposed to do is that you are supposed to learn a model. Okay, you learn a model. Okay, what that means is you have a model for probability of label given uh, a particular data, a particular image. Okay, so this is what do you mean by learning a model? So this, you, as you can clearly see, is a conditional probability. All right, so you are supposed to tell what's the label, whether it is, what's a chance that given a particular image, this particular image is of a cat or not a cat. So it's something like this, or a brain tumor or not a brain tumor. So this is a classification problem, and this conditional probability appears there. Similarly, you can also think about another problem which is called as regression. Okay, so what is regression doing? So this is this linear regression, or and generally this kind of a problem where what you are talking about is you are supposed to identify, like let's say what you are given, instead of pictures of cat, let's say you are given a set of attributes of a house. So house details. Okay, so for example, this house, let's say, is in Mumbai. Okay, and it is 3 bedroom. It is in this district number 5, whatever that means, and its area is 1,500 square feet. Okay, and then 2 bathrooms. And then what you're supposed to do is you are supposed to identify what is the price. So let's say this is some 1.5 crores, something like this, and then you are given a lot of house details. Okay, so this is called as this is called why, because this is called a regression problem, because instead of having 0 1, you are supposed to identify y which belongs to r plus. You are supposed to tell what is the price given a set of features about the house. So these are called features. Okay, and in this problem, what you are actually doing is conditional expectation. You will say, what is the conditional expectation of y given the set of features? So that is typically indicated by x. Okay, x, let's say t, something like that. Okay, so this will be you are given several attributes, x1, t2, okay, all this way, and then you basically identify this. So this is a problem in conditional expectations. So conditional probability and conditional expectations forms the backbone of your machine learning. Okay, so see, there is always a way in which you can just go through some courses in Coursera and just forget about the probability behind it. But if you have to anytime try to come up with a better algorithm on your own, then you need to understand the math behind it. Okay, so yeah, so okay, so you understand this. Like for example, you might be able to solve a ton of math problems without really knowing what is the math actually doing. Okay, so this is, yeah, it's up to you what level of details you want to learn. But when we are teaching a course like this, conditional probability and conditional expectations are very important. So that's why we are spending a bit more time on this. Okay, so let's continue on this discussion. So what we had seen is that we had talked about conditional PMF. Okay, we had talked about this is for discrete case. And then we had talked about conditional PDF. This is for continuous case. And then we had seen one of the most important formulas, which is the iterated expectation. Okay. And I had also told you that expected value of x given y is like g of y. Okay. And if you want to evaluate for y equal to y, to evaluate at a value of y equal to small y, what you do is you just say this. This is analogous to g of small y. Okay, so when you are taking the expectation outside this expectation, so if you have to write one step, let us say, if you want to write one step for continuous case, this will be an integration. Okay, this will be expected value of y equal to small y, fy of y dy. Okay, so this is what we had discussed. We saw several examples around this. Okay, are there any questions in these discussions so far? Okay, so let's move on. So after this, so I want to introduce what is called as total variation formula. Okay, so but for that we need to let's look at a simple example, because that is a relatively more complicated thing. So let's look at an example which is given in Sitsiklis notes. Okay, so this is a very interesting example and very simple example. Okay, so there are two sections in a class. So example. Okay, so assume that there are two sections. Of a particular class, of a class. So maybe class 5, class 10, or let's say semester 3 of IIT Go, for example. Okay, there are two sections, and students are divided into two sections. So section 1, which is indicated by small y, has 10 students. And section 2, which is indicated by y equal to 2, has 20 students. Okay, then further, what you are given is that what is the, so now of both these students, you have also given, there is a random variable x, which is the marks obtained. Now, what we are given is section 1 average. Section 1 average is 90. Okay, and section 2 average is given to be 60. Okay, so let me ask the class if you have not yet seen the lecture, so you may be, so what is the how do we write this in the language of conditional probability, conditional expectation? Anybody? How do we write this as conditional expectation?
Expectation of y equal to 1 given that x equal to 90 into f
no, what is this 90? I'm asking, what is this 90? What is in the language of probability, how do you write this 90?
So expectation of
expectation
x
of x
given y
y
equal to 1.
Yes, yes. So that is what I was asking. Okay, so this is expected value of x given y equal to 1. This is 90. And then expected value of x given y equal to 2. This is 60. Okay, so now I told you that this thing, expected value of x given y, is a function of y. Okay, so let's try to understand how. So to understand this, all you need to do is write basically in this manner: expected value of x given y is equal to 90 when y, capital Y, is equal to 1, and is 60 when capital Y equal to 2. So this you can now see how expected value of x given y is this. Okay. Now, another way, if you want to talk about average from what you have been learning when you were in class 12th, if you want to write that, what that is actually is 1 over 10 plus, let's say, section 1 students, let me indicate by x1 and I. And there are 20 students, so this will be 1 to 20, right? So that's what it is. There are 20, no, 10 students. So this is 90, right? This you have seen. So similarly, if you want to write this second thing in the language of what you have been learning in your class 12, this will be like 1 over 20 into summation I equal to 1 to 20 of xi, but here there will be 2. Let me write a small xi, otherwise you will think it's a random variable. It's not. Okay. So this is 60. So now if you want to talk about the overall average, what you will do, if you want to take overall average, not in the language of probability, but in general, if you want to do this, it is going to be sum over all the students across both these classes. Okay. So sections, let me call it as y equal to 1 and 2. And this will be I equal to 1 to ny, number of students in that section. Okay. And this divided by total number of students. So there are 30 students, right? There are 30, yes, 30 students. So this will be actually, you can do it by doing 19 to 10. That is the sum of the marks of the students of the first section plus 60 into 20 divided by 30. Okay, so this number turns out to be 70. Okay, so this, you know, this is all the things that I have written so far is the usual thing that you would do in class 12th, but in the language of probability, if you want to do that. So we know that expected value of x is nothing but expected value of x given y, right? So let's do that. So we have to do expected value of x given y equal to 1 into probability that y equal to 1 plus expected value of x given y equal to 2 into probability y equal to 2. Okay, so now in order to understand what is probability y equal to 1, so what is probability y equal to 1? Can anyone tell me looking at these numbers?
One third.
Yeah, thank you. So this is 1/3 because there are totally 30 students. 10 of those students are in section 1, so it's 1/3. Okay. So now we can now start putting the formula and start computing this. So this is it 90 into 1/3 plus 60 into 2/3. All right. So if you do this, so this will be 30 and this will be 20, 40, 70. Okay. So the whole idea of having this discussion in this manner that Sitsiklis does is just to make you realize that this conditional probability, conditional expectation is not something totally different from what you have been learning earlier. It is just a language. Okay. I hope this example makes it clear to people who might have had doubts before. Okay, so now we have seen this. So let us now talk about a new object that you have not seen before. Let me just make some space over here. Okay, so now I have been telling you from before that expected value of x given y is like a function of y, right? So in fact, it is also a random variable, right? When y is random, a function of y is also a random variable. So this is also a random variable. So now when you have something which is a random variable, I can also talk about the variance of it. Okay, variance of expected value of x given y. So this is what we will talk about now. Okay, we have already talked about expectation, expected value of x given y. This we have already talked about. Okay, that is equal to x. So now let us talk about the variance. Okay, so now what it is trying to do is like, so you have given this. So this is the function, right? this is the function, okay, which is the function of y. Y equal to 1 happens with probability 1 over 3. This is with probability 2 over 3. Okay, so this is what is given to us. Now, when we say variance, what we are essentially asking is what is the variance of this random variable? That's all. All right. So let's try to do that. So variance, if you remember, so the formula for a variance. So let's say variance of some g of y is what? It's expected value of g of y squared minus expected value of g of y whole squared. I hope this you remember. If this is proving to be difficult to remember, it is this, right? If you expected value of y squared minus expected value of y whole squared. So it's very similar to that. So let us plug in this and try to evaluate this. So this will be expected value of x given y square minus expected value of x given y whole squared. Okay, so don't get confused. These are all things that you have already learned, but just try to remember this. Okay, this is one formula. So this is formula 1. There was also one more formula. So let us recall both of the formulas so that you understand the thing. So there was another formula of variance. So let's write that. So variance of y is also given by expected value of y minus e of y whole squared. Okay, this is another formula. Okay, in terms of formula 2, how will this be? This will be expected value of so the first thing is as it is. So x given y minus, okay, x given y minus expected value of x given y, which is nothing but expected value of x, okay, whole squared. So let us pick formula 2 to evaluate this. So let me write what is expected. So this, I'm sorry, this has to be there, right? The inner thing, y has to appear as it is, not just without the expectation. So what is the expected value of x given y as a function of y? There are two things. When y equal to 1 and when y equal to 2, this is 90, this is 60. So let's do that. So this will be so this will be essentially, this will be expected value of x given y equal to 1 minus expected value of x whole squared into probability y equal to 1 plus expected value of x given y equal to 2 minus expected value of x whole square into probability y equal to 2. Okay, so we know what is this. This is 90. So this will be 90 minus 70 whole squared. Probability that y equal to 1 is 1 over 3 plus 2 over 3 into 60 minus 70 whole square. So this term, when you do the simplification, apparently this turns out to be 200. Okay, so now what did we compute? So we computed this quantity called as variance of expected value of x given y. Okay, so if you want to understand the mathematical meaning here, okay, so what we are saying is how much does, so let me write this thing in it again. So variance of expected value of x given y. Okay, so what is expected value of x given y? This is like section average. Okay, is this clear? So this is section average. Okay, and what does variance of expected value of x given y says? Talks about spread of spread slash variability across sections. Okay, I hope you understand this two ideas. Okay. Okay, expected value of x given y is for a given section, what is the value? Variance is telling across sections how much is the marks changing. Okay, these are the two things that you should understand. So these two quantities we have computed. Are there any questions so far? Let me just quickly take a small pause in this discussion and let me just check if everyone is following so far. Can I have a quick check? Can you please let me know if things are okay? Okay, very nice. Okay, thanks. So coming back. Okay, so this it's important to understand the like the interpretation of these quantities. Okay, so that is why we dealt so much with this. So now we can also talk about another quantity, which is variance of, yeah. So the other quantity that now we are going to talk about is, so we are going to talk about variance of x given y. So this is something that may be difficult for you to understand, but let's try to understand this because there are so many things that are coming in. So you may be getting confused. Okay. So we have seen this. We have seen this. This is a new thing. I hope you can see this. So what is this trying to say? Okay. So given a section, how much does the marks change? Okay. So this one again, let's try to write the definition. So this is also a function of y. Okay. So why? Because if y equal to 1, this will be some value. If y equal to 2, it is some other value. Okay. Now it is given as part of the problem. So in the example that we are discussing, okay, in the example it is given. So the variance within a section is given to you. Okay, so what is given? Variance of x given y equal to 1 is 10, and variance of x given y equal to 2 is 20. Okay, so in section 1, where the like in section 1, this was also given as part of the problem, right? Within the section 1, I had told you what was the average. Okay, and within section 2 I had told you what was the average. This was 60. So likewise you are also told the variance. Okay, so what is the formula? Let us try to recollect this. So variance of x given y equal to 1, how do you compute? You basically look at all the students. There are 10 students in this. Okay, then you look at how much each student has obtained. Xi of y equal to 1 minus the section average. What is the section average? 90. Okay, and you take the average of this. So this is variance of x given 1, x given y equal to 1. This other thing is variance of x given y equal to 2. There are totally 20 students. Okay, so this small I goes from 1 to 10. Small I goes from 1 to 20. Okay, xi2 minus 60. Okay, so these two quantities have been given to us and it is 10 and 20. Okay. So now what we can talk about is now what is the average variance. That is what we can talk about now. Okay, so what is an average variance? How much the spread changes, what's the average value of this? If there are 10 sections, each section has some variance. What is the average variance? So for that, the concept that we are going to talk about is expected value of variance x given y. Okay, so this is again very easy. So let us just compute this. So what is this? This is going to be variance of expected value of x given y equal to 1 into probability y equal to 1 plus variance of x given y equal to 2 into probability y equal to 2. Okay, so let's plug in the formulas, plug in the values and get this number. So we have all the details here. So 20 and 10, right? So 10 into 1 over 3 plus 20 into 2 over 3. and this number is actually 50/3. Okay, so we have talked about a lot of things. So let us just summarize before we move on to new concept. Okay, so what and all we have seen. First thing, we saw expected value of x given y. So what is the interpretation? This is like section average, right? Given y is equal to 1, what is the section average? Okay, this is a function of section. Depends on which section you are. All right, this was the first thing that we saw. The second thing we saw was variance of expected value of x given y. Okay, so this is like the variability. Okay, variability across sections. Okay, then the third thing we saw is variance of x given y. Okay, so this is like within a section. Okay, within a section y equal to 1, what is the variability of marks? Okay. Then fourth thing is like expected value of variance of x given y. So what this is saying is like average variance in sections. Okay, so how much average variance is there in sections? Okay, so these are the four quantities. I hope you are able to understand what each of these four quantities means. So
Sir,
yeah.
regarding the point 2 and point 3, sir,
Mm-hmm.
in none of them have we specified y a value of capital Y, right? We have not specified whether y is equal to 1 or equal to 2, right? But
No, this is within this, like expected value of x given y, it is a function of y. So what that means is we are telling what is expected value of y equal to 1, that is, 90, and expected value of x given y equal to 2, this is 60. We have specified this. It depends on, it's a function of y. So we have, this is equal to this.
no, sir, what I
We
mean to
have,
say in the third point, which is variance
hmm,
of x given y, we have like this would go. We have not specified y, so we'll take both the cases, right? 1 and 2. So
yes.
how is it for within a section? It will account for both the sections, right?
No, it is variance. So you have to specify within a section. You have to tell whether y is equal to 1, what is the thing. So, so
And
what
sir,
I'm trying to,
if we then specify y equal to 1 in the second case,
hmm.
what difference will that make? Like,
In this case,
yes, sir. If we take y
you,
equal to 1 in this case.
there is no question of y equal to 1 or y equal to 2. This is a single number.
Okay, sir.
Just I know this is like too much notation, but you try to just calmly look at it. See, this is like your g of y, correct? Yes, this is like your g of y. So when I take variance of g of y, okay, can you specify what is y? Does it make sense to say what y is? If I say variance of x, can you specify what value of x you are talking about?
Okay, so we cannot take y because like both the y will be accounted for this.
Yeah, both the y's will be accounted for. Okay, so since we are taking variance, we are telling, since all the y's are accounted for, what is a y? Y is a section. So we are talking about variability of these marks across sections. Okay, so that's what it is saying. I hope this is better now.
Yes, sir. Thank you, sir.
Okay, so yeah, any other questions? Let me just keep this on the screen for some time, and all of you have a look at it carefully. And if there are any questions, you just let me know. Ramnath, do you follow what's going on?
Yes, sir.
So at this point, allowing this to remain on screen, I will like to remind you that tomorrow Varun is going to teach some things on NumPy. Varun, are you here?
Yes, sir.
Okay. So after Varun's session, there will be a quiz. Okay. So that quiz, again, see, I have tried to reduce your workload, and I have just asked you to see all the lectures till last week. Okay, today what I'm talking about is not going to be in the syllabus, but whatever we have seen till the last week, please go through all of the material. Okay, Markov chains is also not part of the syllabus. Okay, so try to keep it simple. Just go through all the lectures first. Understand whatever is talked about in the lectures, and then if you have still time, then you can see Sitsikili's notes and try to understand the rest of it. Okay. All right, so I hope all the four concepts are clear. So let me just, for the sake of making it clear, driving home this point, what we are having are these four quantities that we have discussed. Okay, these four quantities, again, I will tell you, this is going to be useful in machine learning. Okay, let me tell later how that is useful, but let's just talk about what each of these things are. Okay, so expected value of x given y. Okay, so this is a function of y. Y is the section. Okay, given y section 1, section 2, you will have different marks. So this is like section average, and it's a function of section. Okay, so if y equal to 1 is CS and y equal to 2 is math and computing, then expected value of x given y is telling for CS students what's the expected average marks, for math and computing students what's the average marks. Okay, so this is the first thing. Oops. Let me just okay, so that was the first thing. Then variance of expected value. So this is the first concept. So this and this are closely related. So why do I say that? So now you understood what is the average marks for the math and computing student. You understood what's the average marks of the CS students. What is variance of x given y saying? So this is saying given math and computing students, how much do marks change within that section itself? Okay, and given y is equal to math and computing students, how much do marks change as a function of section? This is also again a function of section. Okay, so this one and this one are functions of sections. The third one, 1 and 3. Just let me just make this box to indicate what we are talking about. Okay, now we are talking about variance of expected value of x given y. So expected value of x given y is a function of section. What we are saying is across sections, how much do marks change? Okay, so if you remember that calculation that we did, variance of expected value of x given y, that we did somewhere up here. You know, if you see, what we are doing is we are taking every section marks and how much does it deviate from the mean and taking the sum. Okay, if both the sections had average marks as 70, okay, so both the sections were such that, suppose math and computing and CS, the average was 70 itself. Okay, then if you compute this, 70 minus 70 is 0 and 70 minus 70 is 0, this quantity will be 0. Okay, if every section had the same marks, okay, variance of expected value of x given y will be 0. Okay, I hope this distinction is clear. Then what we are talking about here is we are talking about expected value of variance. Okay, so basically the two sections have some variability, right? Each section has a variability. So what is the average value of this variability? Okay, so that is expected value of variance of x given y. Okay, so with this, all these things, now we are ready to state what is called as total variance formula. Okay, so the total variance formula is actually, so we have seen one thing, right? We have seen expected value of x is expected value of x given y. This we saw. Okay, it would be nice if variance of x can be connected to the notions like this. Okay, so the variance formula is given like this. Variance of x is equal to expected value of variance of x given y plus variance of expected value of x given y. Okay, it would have been nice if it was variance of x given y. That would have been nice, but it's not like that. Okay, So it's going to be expected value of variance of x given y plus variance of expected value of x given y. Okay, so this is called as a total variance formula. Let us first prove this and let us try to understand how it relates to all these quantities that we have discussed above. So first let's give a proof. So let's start with LHS. So in LHS, let us first take expected value of variance of x given y. Okay. So I have told you like this is a function of y. Okay. So this will be so variance of x given y. So let me write the formula once. Okay, so in the discrete case, okay, this I'm just writing for your, this is not necessary for the proof, but just for you to get the picture, what we are talking about is essentially this. So we are going to take variance of x given y equal to small y into probability y equal to small y, and you take sum over all y's. Okay, so this is the expected value of variance of x given y. Okay. All right. So I hope you understand what this means. But if you want to actually do this, okay, so if you want to actually do this, we have to first understand. So if you want to take expectation, you need to understand what is variance of x given y. Okay, so that's what we will do. So this will be, so we have to understand this, then we have to take expectation of this. So to do that, let's take variance of expected value of y equal to small y. Okay, so this will be expected value of x square y equal to small y minus expected value of, okay, this is just the definition. Okay, remember this definition that I told, variance of x is expected value of x squared minus expected value of x whole squared, right? So here x is been replaced by x given y equal to y. Okay, so I'm just, so wherever x comes here, I am replacing it with x given y equal to y. Okay, so just writing that, nothing has changed. All right. So if you, so this particular quantity on the left hand side depends upon what value of y the big it takes. Okay, so that means if you want to write it in general, this will be, yeah.
Sir, I had a doubt that why had we taken e of x when y is equal to y whole square? In the formula that you have given, we have taken e x square y equal to y e of e. Why have we taken this?
Let me see. So this won't be there. Yes. Thank you. Right now it makes sense, right?
Yes, sir. Thank you, sir.
Yeah, thank you for pointing it out. All right, so this is, now if you want to write in general as a function of y, we have to drop all these y's. Okay, so this is going to be x square given y minus expected value of x given y. Yes, Prakar, this is okay.
Yes, sir. Yes,
Yeah,
sir.
thank you. All right, so now this is what this is. So now we are ready to take expected value of variance of x given y. Okay, so this is a function of y. So now we are taking, let's write this expected value of x square given y. Okay, minus expected value of, okay, so what we have done is like you're taken an expectation. These are two linear terms. So it just applies linearly, right? If you remember, expected value of x plus y was expected value of x plus expected value of y. Okay, so I have just expanded this. So taken the expectation here and taken the expectation here. Okay, so now we can do some simplification. This will be, so expected value of expected value, this you know, when you have two expectations like this will be equal to the innermost expectation, which is expected value of x square. minus this one we will retain as it is. See, if you see Sitsikilis, he doesn't explain this at all. So I think this requires some explanation. Okay, I hope I have made you clear at least this part, how this is come. All right. I hope this is clear to all of you. So let us now do the other part. So what is the other part? We have to derive a formula of variance of expected value of x given y. Okay, so expected value of variance of x given y. So this is what we have to do now. So for this, what we will do is like we will write for variance. How do we write? So we will write this as expected value of x square given y minus. Okay, so basically I'm using this formula, right? Variance of y. Yeah, someone has any questions?
Sir, are we trying to evaluate the second term, a variance of expectation of?
Did I? Oh, I'm writing the same thing again. Okay, thanks. All right, yeah. So I have to do the other way, right? So variance of so this is like too much notation, but it's not really complicated. If you understand the interpretation behind it, it's easy. Okay, so let's do this. So variance of expected value of, thanks for pointing out. So this expected value of x given y is like a function of y. Okay, so this variance will be expected value of, okay, expected value of x given y whole squared minus expected value of the inner quantity. Okay, expected value of the inner quantity, which is, right, and the whole thing we are squaring it. Okay, so this will be again expected value of now this is expected value of x. Okay. So now if you see the two quantities, if you see the two quantities and if you add them up, okay, so if you add the two quantities, this one you notice that this and this are the same but with a negative sign. So these two get cancelled. So basically when you do expected value of variance of x given y plus variance of expected value of x given y, okay, this when you add them up you will get expected value of x squared minus expected value of x whole squared, which is equal to variance of x. Okay, so this is the proof for the total variance formula. Okay, let me just at this moment, given that the proof is over, let me just wait if there are any questions. Otherwise, let me give you some connection how it arises in machine learning. Okay, are there any questions up until this point? Let me just pause and see if people have any questions. Can I have a quick survey once again? So if Advay, so you have some question? Okay. How about everybody else? Is things clear?
Sir, can we just go to the first part?
Yeah. Okay. So which part?
Yeah, this one, sir.
Okay. So yeah. So here, what we are talking about is expected value of variance of x given y. Okay. Variance of x given y is within a class. How much is the variability? Okay. It's
Yes,
a
sir.
function
I
of
just
y.
wanted that the last equation which we have drafted in this first part.
Yeah.
Here. So that this
Is
e of x square term.
how did this come? How did this come? Is this what your question is?
Yes.
Okay, so let me write that here itself. So okay, that's a good question. I mean, yeah, it's worth to discuss this. So let's do that. Okay, so yeah. So what we are having is expected value of x squared given y, right? I'm saying this is equal to expected value of x squared. And the idea is, if you want to prove this formally, what you would do, let's just do it for the sake of it. Okay, so let us take the LHS. LHS will be, yes, who was the one who asked me? Can you please help me here? What the LHS will be? Yes. Okay, I don't remember who asked. Anyway, so it will be x squared given y equal to small y into probability that y equal to y. Okay, and if you want to expand this inner guy, this will be summation. Okay, so you are going to take x squared, okay, into probability that what is the value x takes given y equal to y. Okay, this thing into probability that y equal to y. All right, is this clear so far? Now, if you take the summation again, this will be x squared. This will be probability x equal to x, y equal to y into probability that y equal to y. So into probability that y equal to y. So these two will get cancelled. Okay, so this is equal to expected value of x squared. Okay, so in general, expected value of g of x given y. Yeah, what is this going to be? Anybody?
E of gx.
Yes. Okay, the proof is exactly same. Wherever you see x squared, you replace g of x. Okay, I hope this was this whoever asked this this became clear for them. All right, so that is this. Okay, any other questions? Okay, since I don't hear anything, yeah. So I was just trying to tell you what is the interpretation. So in a machine learning model, there are two concepts called as bias and variance. Okay, so when you try to talk about the total, yeah. So this bias and variance trade-off. Okay, the theory behind this is based on total variance formula. So they are actually very related. Okay, so hence, if you really want to understand this bias variance trade-off, and if you want to formally state, okay, so this is where the total variance formula comes. I will be, I mean, whenever, I don't know, in this machine learning course that you will have next year, whether we will discuss this in detail. But if you do, then this is what will be the central theme in that discussion. Okay, so let us write this. So what we said, variance of x is equal to expected value of variance of x given y plus variance of expected value of, okay. And coming back to what we saw in the section example, what is this quantity? Yes, what is this quantity? So this is the average variability, right, between across sections. Average variability within sections, yeah. So given two sections, each section has some variability. What is the average variability within section? This one is talking about variability across sections. Someone has any question? So this is the total variance in marks. Okay, so this formula is going to be useful, and I hope I have conveyed to you how this formula actually arises. All right.
Sir, for the second term, variance of expectation, won't it be variability of average across the section?
Variability of average across the sections. If you want to say that, variability of average marks, average section marks.
Average is a fixed number, so we can't do that.
No, this is fine. No, this is fine. So see, you have two section marks, right? You have given like this. There are 2 marks. It's like 90 and 70. Okay, so there is some variability here. Okay, if it was 70 and 70, this quantity would have been 0. Variability across section, average marks across section would have been 0. So what I'm saying is, if x given y was 70 and 70, what would have this been, Siddhant? What would have been the variance of this quantity been?
0, because everything's there's no spread.
Same. Yes. So this is what it is. So variability of marks across sections. Across sections. That is what it is saying. Okay. Is this clear?
Yes,
Yeah.
sir.
Yeah. Okay. So I think we have seen. Okay. Let me just quickly summarize whatever we have discussed in this chapter. So basically, what we began was this discussion on. Basically, if you just go back all the way to the top, so we started with conditional PMF, conditional PDF. Okay, we saw the iterated expectation formula. Okay, this is an easy proof. We saw that how that is arriving, and then we saw with an example what it means to say each of these things. We understood why expected value of x given y is a function of y. That we understood. Okay, and then we saw these quantities, these 4 quantities. Okay, these 4 quantities we discussed at length. Okay, I hope I will just flash this for you to see once again. This is an important idea. Okay, so this is like section marks. Every section, how much marks it has. Okay, so I hope I don't want to repeat it again, otherwise it will be very boring. But you have these things in YouTube. And then we saw the total variance formula. And these ideas are very important in statistical machine learning, learning theory. All these things are the places where this will be used. Okay, so with this, I think it's a good time to stop. So tomorrow we will have the quiz. So for those of you who want to respond to the survey, and if you want some suggestions, if you have, please respond to the form. The form is still open. Okay. So basically what we are going to do henceforth is have a little bit more programming. Okay, so that's the general feedback I got. If you disagree, please upload in the survey. Okay, then there may be still something else we can do. And in general, the response that I got is like the class is too heavy, so we are going to cut back a little bit. Okay, and then try to reduce your workload. So these are all the takeaways, and tomorrow Varun is going to teach you a little bit of NumPy for 40 minutes. Thereafter, there will be quiz. Okay, so I think that's all. Have a nice day. Thank you very much. Bye-bye.